going to be talking about calculating the interest rate of a compound interest problem. Our general formula for compound interest is A equals P 1 plus I to the n. That's our general formula when finding the future value. Now when looking for the interest rate, we can take the same formula and rearrange it to get this new formula. I, the interest rate, equals A divided by P to the exponent 1 divided by n minus 1. So in this formula, A is our future value or maturity value. P is the present value or principal value. The n is the total number of compoundings for the duration of the loan or investment. So when calculating n is going to be the number of years of your investment or your loan multiplied by the number of compoundings. Per year. So if you had an investment and you were leaving it for 10 years and your investment was earning an interest rate that was compounded semi-annually, semi-annually means 2 compoundings a year, then you would take 10 years times 2 and your end value would be 20. Once you figured out that portion, you then subtract 1 and that'll give you the interest rate, but that interest rate will be on a periodic basis. So if you had semi-annual compoundings, the interest rate you find here is not the annual rate but the periodic rate. It is how much interest would be added to the principal amount every 6 months, not every year. So if you wanted to find the annual rate, you would have to take this value for I and multiply it by the number of compoundings per year. In the case of semi-annual, it would be 2. In the case of quarterly, 4, monthly, 12, and annual, 1. So we will try an example. And this example says, Jane has charged $2,400 to her credit card. She lost her job and is unable to make payments for 1 year, and then finds that her new balance is $2,897.88. What monthly compounded interest rate was Jane being charged on her credit card? So we know our general formula to find the interest rate. I equals A over P, all to the exponent 1 over n, then subtract 1. So A is our future value. So 1 year later, this was her balance, $2897.88. Her principal amount, she started off with $2,400 charged to her card, all to the exponent 1 divided by the n. Now the n value again is the total number of compoundings. So it's the number of years, in this case 1 year, times the number of compoundings per year. They're asking for what monthly compounded rate was being charged. Monthly compounding is 12 compoundings a year, so we have n is 12. And then we subtract 1 from that. Now when we calculate this, again we have to do it in the proper order. So complete your brackets. You're going to divide this value. Once you've divided that value, you can take it to the exponent 1 over 12. You can actually divide this 1 divided by 12 to get 0.083 repeating, and then you can actually compute that exponent. Once you've computed the exponent, the last thing you do is subtract 1 from it. Computing this all in the proper order will then give us 0.015833.263. Now this is the periodic interest rate, not the annual one. Okay, but to start off, this is in decimal form. We normally quote our interest rates as percentage form. So the first thing I would do is multiply this by 100, so then we have a percentage form rather than the decimal form. So that would be 1.583326.3%. So since this is the periodic rate, this is how much interest is being added on to her credit card balance each month. Not each year. So now that we have this periodic rate, to find the annual rate, you just multiply it by the number of compoundings per year. Since there's monthly compoundings, we multiply it by 12, which gives us 19%. Okay. So this 19% is the annual rate compounded monthly. So we've just completed a compound interest question where we're trying to find the annual rate, not the periodic rate.